Welcome back, everybody. So we got a good jump on polynomial inequalities, or pi, and these are also polynomial inequalities, but they're more in a rational setting. If you remember, rational means the same thing as fraction. So you can see now, for example, number 1, that we're dealing more with fractions now, which we did way back in chapter P. Well, good news and bad news. The good news is the steps are basically the same. If it's not already factored, look at the top and factor it, solve, make a number line, and proceed as we normally did. The only thing that's different now is we're going to have to take into account the fact that you have a denominator. So you're going to do the same idea. You're going to set this one equal to 0 and get that x value and also put that on the number line. So here's the one change you can put in your notes. When you're dealing with a rational inequality, you're going to now look and see what x values make the denominator equal to 0 and add that to your list. And then those numbers, with also the ones from the numerator, you'll put all those in the number line. So don't just look at the numerator, look at the bottom denominator as well. All right, let's try number 1. There we go. So I'm going to write this on a separate page so I can see it better. This problem said, solve for x plus 2, x minus 5 divided by x minus 4 is greater than 0. Now right off the bat, I see that this is not a greater than or equal to, it's just a greater than, so I know that I'm going to be using parentheses and not the hard square brackets. Okay, I'll keep that in my brain. Well, let's solve each piece equal to 0. Luckily it is factored for us, so from the top, this one gives me that x equals -2 on my number line. This one over here gives me x equals 5 on my number line. And now, because he's rational, we're going to deal with the denominator bottom. Solve this one, x equals 4. Okay, so these are the 3 numbers I'm going to place on my number line and test my intervals and see what happens. Here we go. Number line. Now my smallest value was -2, and then 4, and then 5. Again, notice I don't have to put little tick marks for every single value in between. I just want to see the overall intervals. Now if you see here, we've actually divided up now into 1, 2, 3, 4 intervals on a number line. So we have to test all 4. Like we learned before, the best way to do it is let's pick a number in between each one. So from the left, how about something less than -2? I'll pick -3. Something between -2 and 4, 0 is always a great value to try to plug in. Between 4 and 5, that's a little tricky, but I'll put 4.5. And then something greater than 5, I'll just pick 6. Okay, so we're going to plug those, and we're going to plug those all the way back into our original, which means also the bottom as well, guys. So, again, we don't really care about what the actual number answer is when you plug in. I just want to know, is my answer going to be positive or negative? That's all I care about, and then we'll use our inequality symbol to choose which ones we're going to pick. All right, when I plug in -3, now I'm going to pretend, I'm going to use these little symbols to pretend this is the top sign and this is the bottom sign. So when you see that number line, that's what that means. If you have another way of doing it, that's completely fine. This is just my way, so it sort of organizes my work a little bit better. All right, when I plug in, let's try -3 into the top. The first parenthesis will be a negative. The second parenthesis will be also a negative. And the bottom number will also be a negative. So if I multiply the top, I should get a positive over a negative. That overall is a negative. So this interval, this entire interval, would be considered a negative sign. Any number that I plug in less than -2 into that inequality would give me overall a negative number. Okay, let's try between -2 and 4, we choose 0. So if I plug 0 into the first parenthesis, I get a positive. The second parenthesis, I get a negative. And on the bottom, I get a negative. All right. So now, if I multiply the top, I get a negative. On the bottom, I get a negative. Well, overall, that's a positive. So this entire interval would give me a positive answer out. Let's keep going. How about 4.5? Again, it's a decimal, so it's a little bit annoying. But again, just worry about the sign, not the actual answer. So if I plug in 4.5 into the first parenthesis, that's positive. Into the second parenthesis, that is actually negative. And then the bottom, I actually get a very small positive. So multiply all those out, and your answer will be negative for that interval. And then for something greater than 5, I picked 6. So each parenthesis, if I plug in 6 into the first parenthesis, he's positive. Second parenthesis, positive. And the bottom is also positive. That gives me overall a positive answer for that interval. All right, did you get those answers first of all? Good. Now let's go back and check. Our initial, way up here, our initial problem said find where this whole thing is greater than 0. Remember, numbers that are greater than 0 are all positive. So look at second C. Let's see if I can see which ones gave me a positive answer. Well, I have a positive here and a positive here. So it should be this interval and this interval going forward. Okay, now how are we going to write that? That's going to be an interval notation from -2 up to 4. And look and see, are we going to use the hard brackets or the parentheses? Well, because it's greater than and not equal to, we said we're going to use the parentheses. So I use -2 to 4 parentheses, and we're going to join using the union symbol. And we want the other interval, which is 6 and just greater than 6. So everything greater than 6 would be from 6 all the way up to, well, up to infinity. Infinity is always parentheses because we can't bracket infinity. And we're also using the parenthesis on the 6. Here's my final answer, folks. And there you go. Again, just to recap, the one big difference you do is you do look star at the bottom and choose that. Solve the bottom equal to 0 and add that to your number line. It will make a difference. Good job. I'm going to try problems number 2 and on. Well, actually, I'll just do one more. I'll just do number 2. Why don't you go and write this one down? And I'll give you a big hint. Do you notice that on the right-hand side, it doesn't equal 0? Uh-oh. That's a little dangerous. It has to equal 0 on the right side in order to work. So we're going to have to do, like you said here on the little hint here, is we're going to have to bring that 3 over to the left side, set equals 0, and combine everything into one fraction. So here's goal number 1, friends. Can you bring the 3 over and combine everything on the left side into one single fraction? Why don't you pause the video and try that on your own and come on back and we'll see how we do. All right, so I'm going to subtract 3 and I'll get 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. Okay, good. I've got 0 on the right-hand side, but now I have to combine. So we're going to find a common denominator. Way back to chapter P again. So I'll multiply the top and bottom by my common denominator of x minus 5 would work here. And now we're just doing algebra. All right, common denominator is good to go. So why don't we combine our two friends together here? And we get, ooh, be careful of that negative sign. That scares me a little bit. Remember, he's going to hit both pieces here and here. All right, how about combine everything? How about 2x minus 7 minus the 3x, and now minus a minus 15 is positive 15. Let's combine our like terms. We get minus x, and then the negative 7 and the positive 15 gives me a plus 8 over x minus 5. Let's bring the original inequality back in. And that was less than or equal to, well, we moved the 3 over, so he's 0. All right, we're good to go. Why don't you go ahead and solve this on your own, friends? Pause the video and check and see how you did. Now remember, it's a rational function, so you have to also look at the bottom, include that solution in your number line. All right, I'll see you soon. All right, if I take the top is equal to 0 when x equals 8. The bottom equals 0 when x equals 5. So I'll put those two numbers on my number line. Choosing numbers in between, I'm going to pick, well, 0's to the left, that's nice. How about 6 and 10? Okay, when I plug those numbers in, 0 on the top is a positive, and the bottom it's a negative. So overall, this whole interval is negative. For the 6 on the top, he's going to be positive. On the bottom, he's going to be positive. So overall, that interval is positive. When I plug in 10, I get negative on the top, positive on the bottom. So overall, this interval is negative. All right, let's go back and refer up to our original inequality was less than 0, less than or equal to 0. So I'm looking for all my negatives. That would be this interval and this interval. All right, why don't we write it out? Now that's everything to the left of 5. So that means I'm going to go all the way to negative infinity and go up to 5. Negative infinity, just like positive infinity, can't be bracketed, so I'll use a parentheses. And now let me check. Way up here, it's less than or equal to, so I am going to use the square brackets and not the parentheses. So I'll go negative infinity up to 5, and I'll join it with the other interval, which is from 8 forward. So I'll go 8 to positive infinity, parentheses on the infinity, and a hard bracket on the 8. That means every number pretty much less than 5 and every number greater than or equal to 8 will work and make everything less than 0. And that's the answer for that one. Great job, guys.